So, before we get into explaining what source grounding is and how we use it in MetaGrid, I'm going to very quickly give a kind of brief overview of what an AI model and a language model is generally, just to provide a bit of context to explain what source grounding is. So very briefly, an AI model, the important point here is that it's a numeric representation of a real world problem. Computers, they don't understand images, they don't understand text, they only understand numbers. So whenever any AI model is doing anything, it always has to work with numbers. So in this simple example here, you've got an image classification model. It's a handwriting recognition model, and it's going to take the pixel values of the image on the left, the image of the A, and it's going to take those numbers, it's going to process them, and its output is going to be some more numbers. In this case, its prediction for what letter it thinks that image is. Now, language models, they work exactly the same way. Again, computers don't understand text, they don't understand words, they only understand numbers. So all of this has to work as numbers. Now, the important thing about large language models, ChatGPT, Gemini, all these other models, is fundamentally what they do is they're just predicting the next word in a sequence of text. So even when they're having a full-blown conversation with you, they're actually just generating that one word at a time. They predict the first word of the conversation, then the second word, the third word, and so on. So in this very simple example here, if we give a large language model the input to be or not to be, that is it's just going to predict what the last word of this sentence is. And the first thing it's going to do, as I said, has to be in numbers. It's going to do a process that's called embedding. And all embedding means is it's going to take the words of the input and it's going to turn them into numbers to put them into a form that the AI model can understand and can process. So this is just a massive list. There's quite a lot of them. There's probably going to be, within a typical input to an AI model, these embeddings are going to be a couple of million numbers long. So there's a lot of numbers there. Now, there's another list of numbers that an AI model has, and they are called its parameters. Again, I've just put 4 numbers here to represent model parameters. In reality, there are billions, hundreds of billions, maybe even trillions of numbers within a model. Billions of these parameters that kind of control what the AI model knows, how it behaves. So we've got these 2 big lists of numbers, massive list of numbers of the input and a massive list of numbers of the model's parameters that is essentially an encapsulation of everything the model knows. And what the model's going to do, it's going to take these 2 lists of numbers and do a load of maths. As I said, these are 2 very big lists of numbers. So there's a lot of maths going on. And the output of all of that maths is some more numbers, which is essentially just the AI model's prediction of what the next word is. So in this case, to be or not to be, that is the AI model predicts that the next word is going to be question, because this is a sentence it will have seen a lot in its training data. That sentence will be somewhere in those model parameters, so it can correctly predict that. So all of that is just a bit of context, a very quick high-level overview of how large language models work. But the important point for source grounding, which I'm going to talk about now, is that there are 2 different places that an AI model can get information from. And it's one of these 2 lists of numbers. It can either get information from its inputs that you give it when you ask it to generate something, or it can get information from its parameters. And parameters are the thing it's learned when it was initially trained. So what is source grounding? You might have also heard the terms retrieval augmented generation, or RAG, or in-context learning. Generally the reason we use source grounding is because RAG already means something in the world of MetaGrid. It means red, amber, green. So just to avoid confusion, we tend to stick with source grounding. But if you're reading about AI and you see the term RAG, essentially it's the same thing. But it's a method of giving an AI model some extra context, some extra information about you or your organization or the project you're working on, so that it can answer questions or generate content that is more relevant to you and to your organization. So the question that kind of comes up here is, isn't this just training or fine-tuning? And the answer is no, because people, when you hear people talk about AI, you will often hear the word training used, and it's often used incorrectly, because training in an AI sense means something very specific. What training means is that you're updating the model's parameters, you're changing the model itself. So model training initially is essentially what the model knows out of the box without any extra information or context. Model fine-tuning, which is another term you may have heard, that's about further training the model on domain-specific information or to do a specific task. Again, you're updating the model's parameters, you're changing the model itself. And the important point about training and fine-tuning is once you add information into an AI model via training or fine-tuning, that information is in there forever. You can never get it back out again. Whereas when you do source grounding or RAG, you're just adding that information as an input when the model needs it. You're not changing the model itself. You're not updating its parameters. So that knowledge is not in the AI model forever then. Here's a quick sort of comparison of the two. So as I said, when you train an AI model, you're actually updating the model itself. You're changing the model. You're updating its parameters so that it now knows the information you're giving it forever. It's impossible to get that information out of the AI model once it's in there. You have limited control over when the AI model is going to use that data. It might use it when, it might use irrelevant data when you don't want it to, or very importantly, it might share that information with other people who shouldn't be seeing that information, with other people in different organizations if they're using the same AI model. If you train an AI model on your organization's data, and that's a shared model that other people are using, there's no guarantee that other people outside your organization won't see that data in their AI responses. Now, the very important point to make here is that we don't do that. In MethodGrid, we do not train AI models on any of your data. So all of those bad things that I've just said, there's no risk of any of that happening because that's not what we do. What we do instead is source grounding, which, as I said before, there are two places that an AI model can get information from: its parameters, or the other place, and this is where source grounding comes in, is its input. So what we do instead is when we ask the AI model to do something, whether we're asking it a question or we're asking it to generate content within a project in MethodGrid, the first thing, it goes away to all of your different sources, your information, your organizational knowledge. It finds the relevant bits of information, puts them into a form that the AI can understand, and then it passes those to the AI model along with your prompt. The important point is the AI model does not remember that data. It's used to generate one single output and then is forgotten. We're not changing the model. We're not updating the model's parameters. And very importantly, from a security point of view, people outside your organization or other people who might use that AI model later will not see your data because it's not there. So that is broadly the difference between training and source grounding. A quick sort of overview of when you would use source grounding versus just using a plain vanilla AI model. If you ask an AI model a fairly generic question, for example, what is the capital of France? That's something that the AI model will have seen in its training data, probably a lot. And so that knowledge that Paris is the capital of France is encapsulated within the AI model's parameters. You don't need to give it any extra information in the input. It can just look in its parameters, it can get the relevant information, and it can answer your question. Whereas when you ask it a question that is specific to your information within a MethodGrid context, you're asking it for information about your project, that's not information that the AI model will have initially been trained on. That information isn't in the model parameters, so we need to pass that in as part of the input in order for it to be able to answer questions about it or generate content based on that. Now that is the end of my explanation. I'm aware it was a very quick, slightly technical, high-level explanation of AI and source grounding. So if there are any questions about any of that, please do let me know and I will answer them.